Hi everyone. In this video, let's solve Leetcode problem number 5, which states that given a string S, return the longest palindromic substring in S. Now, before we proceed, let's understand what is a palindromic substring. A palindromic substring is something that reads the same forward and backward. For example, this string ABA reads the same forward and backward. And similarly, this example string also reads the same forward and backwards. Now that we know what is a palindromic string is, how do we check if a string is a palindrome or not? There are two ways to do this. One, you start from the center of the string, center character of the string, and then move outwards. Every time you move outward, check if the characters are same. For example, in this case, I'll be moving outward and check if the characters are same. If they are same, then continue moving outward. And now we have reached the end of the string. There's no other characters to move outward. The string is a palindrome. And similarly, let's take another example for a string of even length. And this time, let's start from the outer characters and move inward. So you do the same thing, you move inward. Every time you move inward, just check if the characters are same. And once we reach the center two characters of the string, that concludes the program. And this example is also a palindrome, which is of even length. The time complexity of this sliding window technique to find if a string is a palindrome or not is big O of n. Since it's just a linear operation, we just iterate over each characters one time. It's big O of n. Let's get back to our original problem, which is to find the longest palindromic substring. So let's take this as our example string. The brute force approach for this problem would be to find all the substrings and then check if these substrings are palindrome. And if they're palindrome, just make a note of the length of the palindromic substring, and then at the end, just return the max length of the palindromic substring. So for example, if we start with the first letter B, obviously B is a palindrome since it treats the same forward and backward. Now let's include this next character, BA. This is not a palindrome because it treats different if we read it from backwards. And if we include the next character, BAB is a palindrome. And let's move forward. If we include the next character, this is not a palindrome. And finally, if we include the last character, that is also not a palindrome. So until now, our longest palindrome is BAB. And let's continue this with the second character now. So obviously second character E is a palindrome. If we include the next character, that is not a palindrome. And let's include the next character. This is a palindrome, and if you remember from the previous iteration, BAB was our longest palindrome until this point, and ABA is of similar length. And even in the example, the explanation says that we can return ABA or BAB. So let's proceed. And this is not a palindrome. So as you can see, we can repeat this for all the other characters as well. And the time complexity to find all the substrings given a string is big O of n square. And the time complexity to check if a substring is a palindrome or not is big O of n, if you recollect from the sliding window technique. So the overall time complexity of this approach is big O of n cube. We can use the same sliding window technique to optimize this problem. Just to recollect, we check if a string is a palindrome or not by starting from the center and then moving outwards until we reach the end of the string. And at each iteration, we check if the characters are same. If not, then the string is not a palindrome. So we continue until we find a different characters in the boundary, or if we reach the end of the string. And if we take a string of even length, again we do the same thing. This time we start with 2 characters because the string is of even length, and then we move outwards. Now let's try to use this logic of starting from center and try to see if we can optimize our solution to find the longest palindromic substring. So given this string, now we are just going to find all the palindromic substrings that are centered around each character. So to start with, let's take the first character A, and the color code should explain what we are dealing with at each iteration. So currently, to start with, the right and left pointers point to the first character A. Now, A is a palindrome, so we're just going to update our longest palindromic substring to A until this point, and then we try to move forward. Since we are at the leftmost character, we don't have any other characters to move to, so let's move on to the next character. Now again, this time also, the right and left pointers point to this character, and the longest palindromic substring is already of single length, so we need not update anything. And now when we expand, we see that the left and right pointers point to different characters. So obviously this is not a substring. So let's move on to our next character. Now the right and left pointers point to the character B, which is a substring of length 1. And let's try to move outwards. We see that the right and left pointer now point to different characters. So we are just going to continue with our logic of moving to the next character. Again, this is centered around the substring, which is of length 1. When we expand, we notice again that the 2 characters are different. So we are just going to continue with the next character. Again, this is a substring of length 1. We move outwards, and the right and left pointers point to different characters. So we continue with the last character. And since this is the last character, there is nothing to expand to. Now we are going to continue the same logic, but this time the right and left pointers will point to 2 adjacent characters because we are trying to find a palindrome of even length. As you can see, currently we have a substring which is a palindrome of length 2, and this is longer than the previous longest substring. So we are just updating the longest palindromic substring. And we just move to the next 2 characters because there's nothing to expand to. And when we move to the next 2 characters, these are different characters, so obviously it's not a substring, so we just move to the next 2 characters. And now we see that we are pointing to same characters. So let's expand to right and left. We see that we have same characters again, and now we update the longest palindromic substring. And let's proceed. And now we have again the same characters pointed by right and left pointers, and we update our longest palindromic substring. We can continue this with the remaining characters, but since we already have a substring that is whose length is equal to the length of the given string, obviously we are not going to find any more string that is longer than this. So let's see how we can implement this. Before we implement the main function, let's write a helper method. Now this helper method is going to take the input string, the right and left indices, and just going to return the longest palindrome that is centered around the right and left indices. So to start with, this will take string s and the left index and right index and also the current longest palindrome. That way we can check if the palindrome that is centered around the current left and right is longer than my current long palindrome. And this is just going to have a while loop The while loop will basically have boundary conditions such that the left is always greater than 0 and read is always less than string's length, so that we don't run into out of bound exception. And the other condition is the characters pointed by left and right are same. So if these conditions are met, then the current substring is a palindrome. Now we need to update the long palindrome if its length is shorter than the length of the current substring. So the length of the current substring is simply right minus length plus 1. And if this is the case, we are just going to update the long palindrome to be the substring from left character to the right character. So left of length right minus left plus 1. So all this thing does is it takes the substring that starts at the index pointed by left of length right minus left plus 1. And we simply update the boundary. So left minus minus and right plus plus. So this will just expand from the current center. And once this while loop is done, we are just going to return the long palindrome. Okay, now let's make use of this helper method to find the longest palindrome. So this will be my return variable. So I'm just going to assign this to empty to start with. And then we'll run a for loop that iterates over the characters of the input string. And for each character, we're just going to find the longest palindrome centered around that character. So this is going to be just simply calling the helper method. And let's pass the input string, and the left and right to start with, it is just going to be the same character because now we are finding the palindrome of odd length. And let me pass the current long palindrome. So once this is done, we are just going to use the same function call, but this time we'll simply increase the right pointer by 1. That way we take two neighboring characters to find the palindrome of even length. Note that I need not even verify whether I plus 1 is within the string's length, because that will be handled by this logic. This basically checks for the boundary condition. And once we are done, we are just going to return the long palindrome. Let's run the code to see if the test cases pass. As you can see, both the test cases pass. Now let's submit it. Let's move on to the discussion to see how we can solve this problem through dynamic programming. Let's look at some of the conditions that a string has to satisfy in order for it to be a palindrome. The first base condition is a substring of length 1 is always a palindrome. And that is obvious, as you can see from these examples. If this is a string of length 6 and it has index starting from 0 till 5, all these substrings that are of length 1 is obviously a palindrome. And that is our first base condition. Now let's look at a substring of length 2 and see what happens. So a substring of length 2 can be a palindrome only if the two characters are same. Otherwise, it is not a palindrome. So in this example, the substring that starts at index 0 and ends at index 1 is a palindrome because both the characters are same. Whereas in this example, because the characters are different, this particular substring is not a palindrome. Now let's expand our conditions for substrings that are greater than 2 in length. So let's look at this substring that starts at index 0 and ends at index 3. The boundary characters, or the characters pointed by the right and left pointers, are different here which means irrespective of what is contained within this boundary, this whole substring that starts at 0 and ends at 3 can never be a palindrome. Let's look at a different example. Here, the right and left pointers are pointing at index 0 and 4, which has same characters. So this can be a palindrome only if the inner substring that starts at index 1 and ends at index 3 is a palindrome. Otherwise, this substring is not a palindrome. And for this example, the inner substring is not a palindrome. So this substring that starts at 0 and ends at 4 is not a palindrome. Let's look at a different example. So for this example, the right pointer and the left pointer points at the same character. It starts at 1 and ends at 4. Now this whole substring that starts at index 1 and ends at index 4 can be a palindrome only if the inner substring is a palindrome. And we know by our one of the base conditions that the inner substring is a palindrome because it is of length 2 and it has same characters. So to summarize, the third condition for our substring list is the boundary characters should be same. Boundary characters are nothing but the characters that are pointed by the right and left pointers, and they should be same, and the inner substring should be a palindrome. And how do we find the inner substring? If my right and left pointers point to index I and j, then the inner substring is a substring that starts at index I plus 1 and ends at index j minus 1. So in our example, the right pointer points to index 4 and left pointer points to index 1. In other words, I equals 1 and j equals 4. So our inner substring is going to be the sequence of characters from I plus 1 till j minus 1. I plus 1 is nothing but 2 and j minus 1 is nothing but 3. So the inner substring is the substring that starts from 2 and ends at index 3. So to summarize our set of conditions that we discussed earlier, the middle characters should be same if we are of even length. So in this case, if the substring is of length 2, then both the characters should be same. So that will be our first base condition. And second condition is if we are dealing with the boundary characters, then the boundary characters should be same. The inner substring should be a palindrome. So if we expand further on this example, the right and left pointers or the boundary characters are same, and the inner substring is already a palindrome, so the whole string is a palindrome. Okay. Once we know that the inner substring is a palindrome, how do we find the length of the string that is bounded by the left and right pointers? Okay, that would be whatever the length of the inner substring is plus 2. The 2 is to account for the right and left pointers. So in our example, the inner substring is of length 4, and we know that the right and left pointers are same here. So the length of the substring that is bounded by the right and left pointer is 4 plus 2 for the two boundary characters. Now let's take these conditions and try to solve the problem in a dynamic programming approach. So I have a matrix of size n by n, and n here is 5. So the input string here is ABA, BA. And just for convenience, I just added the indices of each characters right next to the character. The top section that you see there in the matrix is my ending character, and the section that you see at the left is the starting character. In other words, the value pointed by the left column is the index I, and the top section is my index j. And we know that a substring of length 1 is always a palindrome. So if I take this as an example, let's say I start from index 0 and end at index 0. We know by our base case that this is of size 1. And this is applicable as long as my I equals j. So if we just move diagonally, all these diagonal values are going to be 1 because this is nothing but the substring of length 1, and substring of length 1 is always a palindrome. This 1 points to the length of the substring that starts at this particular I and ends at this particular j. So in our case, I equals j, which means a substring's length is 1. So we are just going to fill the value 1 across the diagonal as we move. Okay, we are done with the main diagonal. Now let's move to the next diagonal that starts at 0 and ends at 1. So what does this cell signify? This cell signifies a substring of length 2 that starts at 0 and ends at 1, index 1. And our other base condition is if the substring is of length 2, the two characters should be same, otherwise it is not a palindrome. Because it is not a palindrome, we are just going to fill 0 in this cell. Now let's move to our next cell. Here again, the substring starts at index 1 and ends at index 2. But then the characters are different, so this substring is not a palindrome. And we move forward. This again is not a palindrome because these are two different characters. And our last substring of length 2 in this diagonal is also not a palindrome. Now let's go to the next diagonal. Now we completed our two base conditions. This is the a substring of length 3 now, which starts at 0 and ends at 2. So my I is 0 and j is 2. How do we check the inner substring? Inner substring is nothing but the substring that starts at I plus 1 and ends at j minus 1. So in our matrix, that is going to be 1, 1. Since I is 0, I plus 1 is 1, and j is 2, so j minus 1 is 1. So the value that we have in dp of I plus 1, j minus 1 is my inner substring. And we are going to check this value because the string that is at ith position and jth position are same. So if we continue, we can generalize the value like this. So as long as the characters are not same, I'm just going to add 0. 0 simply means that it is not a palindrome. If I have same characters in I and jth position, then I'm simply going to check the value that is there in the I plus 1 and j minus 1 position. That is going to give me the length of the inner substring. Now, if my inner substring is 0, that simply tells me that the inner substring is not a palindrome. So if the inner substring is not a palindrome, then dp of I, j is simply 0, irrespective of whether the characters are same or not. And my final condition, if the characters are same, if the character that is at ith position and jth position are same, and if my inner substring is having a non-zero value, then we are just going to update our current cell to that value plus 2 for the boundary characters. So for this example, I'm simply going to look at dp of I plus 1, j minus 1, or dp of 1, 1, which already has a value of 1. And we're just going to add a value 2 here. So this cell is going to have 3. Okay, now let's move forward to the next cell in this diagonal. Again, in this case, the character at ith position and jth position are same. So we're just going to look at the diagonal value, which we have 1 here. So we're just going to add 2 like before, and the value for this cell is 3. Let's move forward. And this substring, again, it starts at 2 and ends at index 4. And the characters at index 2 and 4 are same, which means we are just going to look at the diagonal value, which is telling me the length of the inner substring. And we're just going to add the value 2 here. So this is also 3. Okay, let's move forward. Here, the characters at 0 and index 3 are different. So we don't even need to check the diagonal value because my boundary characters are different. This is not going to be a palindrome. So we can simply update the value 0 here. And let's move forward. This is same as the previous example. Here the characters are different. Characters at index 1 and index 4 are different. So we are just going to update this cell to 0. Let's move to the last cell. And this is the last cell and the last diagonal that we are going to process. Here the substring starts at index 0 and ends at index 4. So basically the whole string. And we have the same characters at index 0 and index 4, which means we are going to check the value of the diagonal, the I plus 1 and j minus 1 position. And that is going to be 1, 3, because my I is 0 and j is 4. So I plus 1, j minus 1 is nothing but 1, 3. And that has a value of 3. And we are just going to add 2 to this. So this cell is going to be 5. And this 3 is nothing but the length of the inner substring bounded by index 0 and index 4. And the inner substring happens to be a palindrome here, BAB, which is of length 3. And we're going to add 2 to this value in order to account for the boundary characters, and the value is 5. Notice that we don't need to fill the bottom half of the matrix because that is basically a not applicable scenario. You can't have a substring that starts at index 1 and ends at index 0. So we don't need to fill the last half of the matrix. And after we fill all the values, we notice that 5 is the max value in the matrix, and hence the length of the longest substring here is 5, which starts at index 0 and ends at index 4. The time complexity of this problem is going to be a big O of n square, mainly because we are trying to fill the values of matrix which is of size n by n. So to summarize our dynamic problem solution, we are going to start with the matrix of size n, where n is the length of my input string. And the first thing that we want to do is just set all the values of my diagonal that starts from 0, 0 till the n minus 1 position to 1, because that signifies or that represents the substring of length 1. And one of our base condition is substring of length 1 is always a palindrome. So we're just going to fill 1 in that diagonal. After that, we move to the diagonal that starts from 0, 1 till n minus 2, n minus 1. And this value is going to be 2 as long as the characters at I and j are same. And this is also one of our base condition. So once we fill these two diagonals, then we start filling the remaining cells based on two conditions. One, the character at I and j should be same, and the value at I plus 1, j minus 1 should be greater than 0. If it is equal to 0, then the inner substring itself is not a palindrome. So we are just going to set the cell to 0. If not, we're just going to take the value at I plus 1, j minus 1 and add 2 to it. 2 is just to account for the boundary characters. Now, whenever we update the matrix with a non-zero value, we are just going to keep a variable to keep track of our current max value. That way, once we are done with populating this matrix, we're just going to return the index corresponding to the max value. And that will be the starting and ending position of the substring. Okay. Now, before we proceed to the implementation, let's see how we can traverse or iterate the matrix diagonally. So to start with, we are just going to iterate from this diagonal, like from this cell to the bottom cell, pointed by the arrow mark. So here, my first iteration is going to be visiting 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. So notice that in the first round of iteration, the difference between I and j is same. And this is because we are iterating the matrix diagonally. So basically, we are just going to have two loops, two for loops, since it is an n by n matrix. Similar to any iteration that involves a two-dimensional matrix, this is going to have two for loops. Now, what are my iterator in the first and the inner loop? The inner loop is basically going to increase I and j value by 1, so that we keep the difference same across that iteration. So if you notice, in the first round of iteration, the difference between I and j is always 0. And this diagonal just represents the substring of length 1. So each iteration on the inner loop, we are just going to increase both I and j. And I always starts at 0, j always ends at 4. Or in other words, we are going to keep the I value to 0, the initial value of I to be 0, and the loop is going to run as long as my j is within the length of the string. Now, once we are done with this, we are just going to go to the second diagonal. Now, in this diagonal, we are just going to visit cells 0, 1, 1, 2, 2, 3, and 3, 4. Here again, the difference is same for all the 4 cells, but compared to the first round of iteration, the difference has increased by 1. So the first round of iteration had a difference of 0, and the second round of iteration now has a difference of 1. And this difference value is going to be the iterator for our outer loop. And the loop will start with a difference of 0, and we'll see when this is going to end. The outer loop will end when we are done with the final cell. So here again, the inner loop, we are just going to increment the value of I and j by 1. And let's move to the next diagonal. The next diagonal is going to visit these 3 cells, 0, 2, 1, 3, and 2, 4. So with the pattern that we discussed, the difference is going to be same, but then the difference is incremented by 1 compared to the previous iteration. So the previous iteration had a difference of 1 between I and j. Now we have a difference of 2 between I and j. And if you can see with all the 3 iterations, the loop ends when j becomes 4, or the loop runs as long as j is within the length of the string, and I always starts at 0. That is the consistent pattern. So this will form the default value of the initialization part in the inner for loop. Okay, let's move to the next diagonal. As you can see, this iteration, we are just going to visit 2 cells, 0, 3, and 1, 4. The difference between I and j is incremented by 1 compared to the third round of iteration. And as always, we started with I equals 0, and we continue till j is within the length of the string. And the last iteration, which is 0, 4, and this should give us an idea of what is going to be the condition for my outer loop. So the outer loop is going to run as long as my difference between I and j is within the length of the string. So the outer loop controls the difference, and the inner loop controls the value of I and j. So the difference is going to be from 0 till 4, because once we reach 5 is the length of the string. So we're just going to end the loop there. And in the inner loop, we are always going to have the default value for I as 0, and j is simply going to be I plus difference. And it is going to run as long as j is within the length of the string. So to summarize our logic, in order to iterate diagonally, we're just going to keep the difference between I and j in the inner loop to be same. That way we move diagonally. And to start with, the difference is going to be 0, and we'll continue the outer loop as long as the difference is within the length of the string. And in the inner loop, we're just going to increment I and j so that we move diagonally. And also when we increment both I and j, the difference is going to remain same, which is one of the conditions in order to traverse diagonally. Let's look at the implementation of this dynamic programming logic. Okay, let's implement the dynamic programming solution that we discussed. So to start with, I'll have the 2-dimensional matrix. Let's call it as dp. And okay, before this, I need the length of the string to be stored in a value so that we don't call less.length too many times. And this is going to be n, n. And let's also have a max length variable. This variable is just going to hold the current length of the longest palindrome, and also the result variable. This is what we are going to return. And to start with, let's say this is an empty string. Okay, we need 2 for loops. One is just going to iterate over the difference, and our initial difference is simply 0. And this will continue as long as difference is less than the string's length, and difference plus plus. Now the inner loop is going to I treat the matrix diagonally. So to start with, we are going to assign I equals 0 and j equals I plus diff. And this is going to run as long as j is less than the string's length. And we are just going to increment both I and j so that the difference is always same across the inner loops cycle. And here the base condition is if I equals j, then we know that dp of I comma j is simply 1 because it's just a substring of length 1 and substring of length 1 is always a palindrome. Else if, and the second base condition is to account for substring of length 2, and that is identified if diff is 1, which means we are dealing with substring of 2 immediate neighboring characters. So in this case, dp of I comma j will be 2 if the neighboring characters are same. So if s of I equals s of j, then this is 2 or else 0. So these two are my base condition. Now we enter into this else block, which is where we are going to check if the boundary characters are same and the inner substring is a palindrome. So that we can check by this first condition is simply to check if the boundary characters are same. And if dp of I plus 1 comma j minus 1, I plus 1 comma j minus 1 points to the inner substring. So this will be greater than 0 if it is a palindrome. So if this is greater than 0, then we are going to update the value of I comma j to the inner substring's length plus 2 to account for the two boundary characters. So once we are here, we are done with updating the value of dp of I comma j. Now we need to check the value of I comma j or dp of I comma j if it is greater than max length. So if it is greater than max length, then we need to update our longest palindrome pointed by the result variable. So if this is greater than 0, which means we processed a palindrome. So we need to check if the palindrome's length is longer than my current max length. So if I and j are the two integers that points the starting and ending characters, and the length is j minus I plus 1. So if this is the case, then we are going to update the max length and also the result. Result is nothing but the substring pointed by I comma j. So it starts at I of length j minus I plus 1. Or we already have it. We already have it under max length, so maybe we can use that. Don't need to calculate it again. And yeah, so once we are done with these two loops, we're just going to return the result. All right, let's run the code to see if the two test cases pass like before. Yeah. Let's submit this solution. Hope this was useful. Thanks for watching.